Hello and welcome to Day 6 notes on row reduced echelon form. Today we're going to be using a graphing calculator and an augmented matrix to solve a system of equations. So the previous notes were using matrix equations and inverse matrices to solve systems. Today's a second way to do it, and it's row reduced echelon form. So the first thing we're going to talk about is what an augmented matrix is, and it contains the coefficient matrix, so that should be something familiar to you. It's the numbers in front of the variables, but it's going to have an extra column that includes the constants. So once you write your augmented matrix, then you're going to use your calculator to find the row reduced echelon form. Let's go ahead and do that for the example that's given here. 4x minus y equals 1 and 5x plus 2y equals 24. So I'm going to write my augmented matrix. So like I said, it is the coefficients. So 4, negative 1, but then that extra column is your constants. And then my second row is going to be 5, 2, 24. Alright, so I'm ready to now enter this matrix into my calculator. So recall second matrix, scroll over to edit. It's a 2 by 3 because we have 2 rows, 3 columns. Notice here I entered it. Step 2, once the matrix is in there, you're ready to find the rref. And the way you do that is when you go to second matrix. We haven't yet had to use this. We haven't used the math tool, but it gives us different options of what we want to do with our matrix once we have it entered. So you're going to scroll over once to the right to get to that math, and then you could either scroll down to B, but it's actually faster to scroll up to option B, which is your rref. You're going to press enter. So once you do that, here in step 3, you should have rref on your screen. Don't press enter again, actually. This shouldn't be there. But you are going to choose matrix A, which is the one we entered up above. It's the augmented matrix. And then you're going to press enter. So on your screen, you're going to get a matrix, and within here is our solution. So let's think about what this first row means. Remember that here we had our x values, here we had our y values, and then this was our constant terms. So really this first row, what it ends up being is 1x plus 0y equals 2. The 0y goes away and you get x is equal to 2. The second row is 0x plus 1y equals 7. So again, the 0x part, unnecessary, so you just end up with y equals 7. So your solution you are going to want to write as an ordered pair because it is a system of equations, and that solution would be 2, 7. Now one more thing I want you to notice is this matrix here, this 2 by 2. Notice that it is the identity matrix. It's 1, 0, 0, 1, where you have ones along your main diagonal. That's going to become important once we get to special solutions on the next page. Okay, example 2 here, we have a 3 by 3 system, 3 equations, 3 variables. And if you recall from chapter 3, these were kind of a difficult thing for some of us to solve. So what we're going to do is write our augmented matrix. So coefficients, so 5, negative 5, 5, and 10. My second equation, you'll notice that there is a variable missing, and you do have to account for that. So I have 5 x's, but I have 0 y's. So I do have to put a 0 placeholder in there. Negative 5, and then 5. And then my last equation is missing an x value. I have no x's, so you put a 0 in place there, then a 5, 10, and 0. Enter this into your calculator, and the work that you have to show on a test or quiz would be to write this augmented matrix, write rref in front of it. So then we're going to enter it into our calculator. Then, so this one's going to be a 3 by 2, 3 by 4 because we have 3 rows, 4 columns. Put that into your calculator, go to math, scroll up or down to B, press enter, choose this matrix, press enter again, and you're going to get an answer that will have decimals in it. So you're going to, anytime you have decimals, you want to press math, enter, enter, so that you don't have decimals. It's going to convert them to fractions. So you get 10054, 0, 1, 0, negative a half, and then the last row is 0, 0, 1, 1/4. So again, if I was to think of this as an equation, this would be 1x plus 0y plus 0z equals 5/4. If something is 0, it's not necessary, it doesn't even have to be there, so you basically have 1x equals 5/4. The second equation would be 0x plus 1y plus 0z equals negative a half, so the x part, the z part doesn't matter. You just have y equals negative a half, and then finally the last row will be 0x plus 0y plus 1z equals 1/4. So again, you want to show this first augmented matrix with rref in front of it. You want to show that part. You want to show the answer that pops up on your screen, and then finally you do want to interpret that answer as an ordered triple in this case. Example 3, I would like you to try on your own. I'm going to display just the ordered triple, but remember, for you to get credit, you're going to have to show this first augmented matrix with rref in front of it to show us what you are doing with that matrix. Then you have to display the matrix that appears on screen, and finally you have to write it as an ordered double or an ordered triple, depending on if it's a 2x2 or a 3x3 system. So again, for example 3, I want you to attempt this on your own. I'm only going to show it as an ordered triple. I'm not going to show these first two stars, what you're going to have to show, but I'm only going to show the triple. So go ahead, pause it, and try example number 3. Okay, so the answer you should have gotten is -4, 3, and 6. And if you're ever concerned and you're not sure if you got the right answer or not, remember that you could take these numbers and plug them in. So you'd plug in -4 for x, 3 for y, 6 for z, and then you would see. So like really quick, I would just do that. -12 plus 18, if I plug in 3 for y, minus 12, does that equal -6? It does. Then you would do it for x, -8 plus 3, not for x, but you would do it for the second equation, plus 24. Does this equal 19? Well, let's see, we got 27 minus 8. Yep, so that works. And then the last one, you get 20 minus 6 plus 48. Does this equal 62? Well, 48 plus 20 is 68. Minus 6 is 62. So you can check your answer each and every time to make sure that you did it correctly. Because remember, if you enter that matrix into your calculator and just one entry is wrong, your whole problem is going to be wrong. You're not going to get the right answer, and unless you check, you're not going to have a way of knowing. All right, so let's talk about special solutions when you use rref, meaning no solution or infinitely many. When there is an intersecting point or just one solution, what you get is this identity matrix up here. So again, I had x, 0y, 0z equals 5/4. The second row shows me that I have a y value only, and it gives me the y value. And then the last row, that means there's one z, and it equals 1/4. So with one solution, it's always going to be the answer you get on your calculator. You're going to have your identity matrix is your first 3 rows, first 3 columns, and then you'll get a number, and another number. Okay, so that's one solution. Now, when you use rref and there's no solution or infinitely many, it's actually a lot nicer than with inverse matrices, because with inverse matrices, you just get the error on your calculator and you can't tell, well, which one is it? Here you can. So I'm going to show you an example of what you would get on your screen if you had infinitely many solutions on the line. The first row, so I'm going to do a 2x2. I get something like 2, 1, 4, and then 0, 0, 0. So right off the bat, if something like this happens, you look here, you don't have the identity matrix, so that means something weird is happening. Therefore, you know it's either infinitely many or no solutions. You look to that last row. If the last row, basically what it's saying is 0x plus 0y equals 0, it's 0 equals 0, that's infinitely many solutions. So if that last row is all zeros, infinitely many on the line, and you would write which line you're talking about. Now, no solution, the way that's going to look is, so let me just, hold on, that's right, no solution. Your first row, again, is going to be some random numbers like 1, 1, 2, and then the last row is going to be 0, 0, 1. So as soon as you see here, oh, I don't have the identity matrix, that must mean it's a special situation. This one, if the last row, what this is saying is that 0 equals 1, because that's not true, this is a no solution. Okay, so that's it for rref. Thanks for watching. Have a good one.